Hi, my name is Greg Cielniak and I work at the University of Lincoln. My research is in robotics and in particular its applications in agriculture. So the title of my talk is The Future of Agriculture, Robots to the Rescue. And what I'd like to do today is to highlight some of the reasons why I think introducing robots to agriculture is important, to show some exciting examples of robots performing very useful farming tasks, and also encourage some of you, especially those who are part of the younger generation, to get involved. In particular, I'd like to cover today why agriculture is important globally and locally, what are the current challenges that are faced by the agricultural sector related to jobs and sustainability. I'd like to mention how autonomous agricultural robots can help agriculture and show some of the exciting applications and technology with some examples that were specifically developed at the University of Lincoln. I'd like to also say what is the future of this technology, and finally summarize with some highlights on important skills and existing opportunities for those of you who would like to work in agri-robotics in the future. So, life without agriculture would be very difficult, if not impossible. We all need food, and global population is growing, so we've got 8 billion people currently, with expectations that in 25 years this will be around 10 billions. At the same time, the available land for food production is decreasing, so this is a limited resource, and there is a growing need for more and more nutritious food, which is also produced in a sustainable way, such it does not exploit the planet completely. So all these pressures create a big demand for more efficient ways of food production. So agri-food is the largest manufacturing sector in the UK. It generates over 100 billion of pounds per year and employs 400 million people. Agriculture is also important locally. So Lincolnshire, our county, is a very rural, and a lot of livelihoods depend on food production. The county is leading in producing large amounts of key crops such as wheat, cereals and potatoes, but also poultry and pigs. There are also many companies that produce agricultural vehicles and tools that process and distribute food, so this is really a key important part of the local economy. Modern agriculture, however, is facing some key critical issues which may threaten the entire food production and as a result our lives. The first one is the lack of labor. Jobs in agriculture are difficult, require a lot of skill and training, and at the same time are not very well paid. The young generation wants career in other sectors and moves from rural to urban regions. We are also living longer, and there is simply fewer people in productive age. And this is a global trend in many different countries, not only in the UK, but also in Europe, America, China or Japan. On the other hand, to intensify food production, we heavily rely on the use of different chemicals, which are used to fight disease, pests or weeds. And these chemicals are very costly, become less effective over time, and eventually end up in our food. In addition, the vehicles and the technology that we use to intensify the food production is based on large, heavy and fuel-hungry vehicles. So these are tractors or really large combine harvesters. A modern combine harvester weighs 30 tons. It's really huge. And you can imagine the scale of carbon footprint and damage to soil, wildlife and biodiversity which are caused by these huge machines. So robotics offers an opportunity to change that unsustainable approach through the development of lightweight, electric and intelligent farming robots. These robots can operate with minimal human intervention and therefore support or replace humans in these monotonous tasks. At the same time, the robotics industry creates new jobs which are more attractive, creative, and fulfilling for the young generation of farmers and farm workers. So here I've got an example of how such a robot might look like. So it's one of the robots that we use a lot in our research and which is deployed for many useful applications and tasks. So you can see it's very small, it's reconfigurable, so it's got different modules that you can adjust to a particular application. It's battery operated, it's got autonomy of 10 hours, it's got the GPS for navigation, sensors like LiDAR, which are used for, say, navigation and obstacle avoidance, but also cameras, which allow the robot to recognize key objects such as crops, weeds, people, and so on. In addition, you can equip the robot with different tools, add-ons, which make it suitable to perform different tasks. And when we talk about tasks, the good question is, so what are the good examples? And here I'd like to present some of our recent research, which we've undertaken with other colleagues in academia, tech industry, but also growers from the soft fruit industry. So industry that produces soft fruit, which includes strawberries, raspberries, and so on. The applications of robotics for that soft fruit industry include selective fruit picking, something which is called in-field logistics, so it's transporting crop in the field, plant treatment, so selective spraying or applying ultraviolet light to fight the disease, but also applications which are called farm intelligence, for example, which enable you to predict how much crop you are going to harvest in future, or keep count of all the plants that you've got. To enable these applications, a lot of research has to be undertaken, and for example, in areas such as autonomous navigation, safe human-robot interaction, coordinating fleets of the robots, but also dexterous grasping and manipulation or robust perception. So now I would like to go through some of these applications, look a little bit at the characteristics and what is expected from robots, and show some of the examples of that technology. So the first one is fruit picking, which is, you could call it the holy grail of automation in agriculture. So before we have a look at the technology, let's talk about how humans perform these tasks. So humans are excellent at selective fruit picking. They can assess if the fruit is ripe. They can select the berry that is picked from all the surrounding berries around, and they can do it very quickly. So, for example, a good strawberry picker can pick one strawberry per 2 seconds. So this gives around 20-30 kilograms per hour. So this is an amazing performance, and it's very difficult to match. There is lots of interest in designing robots that can perform the same task, and this is done by many small companies, startups in Europe, UK, and America. But there are still no commercial solutions available, and the reason for that is that this task is technically very complex. So the current prototypes that we can see here on these images, for example, from these different companies, they demonstrate that they can pick the strawberries, but this is done very slowly. Strawberries have to be separated from each other. So these are not yet economically viable solutions. What is also important to highlight here, that it's unlikely that a single robot can address the problem of selective fruit picking on its own. There has to be also a robot that transports the berries, packs them, assesses the quality. So there is a lot a lot of other functionalities important in addition to fruit picking, and hence the farmer needs actually a whole set of robots rather than a single one. So to demonstrate why this task is very difficult, I'd like to show one particular subcomponent of the system, which is the vision system that is able to identify a pickable fruit. And here we've got a video that shows a prototype. This is a very simple academic prototype of a strawberry picking robot, which moves around the rows of strawberries, and it has got a special arm and a gripper that enables the robot to pick the berry. But to do that, the robot also has got the camera, and which needs to determine if the fruit is ready to be picked. So there is lots of problems that needs to be solved there. We need to detect the fruit, then localize to find out where the fruit actually is, so that the arm can reach to particular selected fruit. And there is lots of limitations in current sensors. Sensors are either expensive or they are not of good quality. There are also lots of occlusions because there is lots of plant components, other berries that occlude the fruit. So it's a super challenging problem. Then the vision system has to make a decision. Is the fruit ripe, healthy? Is it of certain quality? So these are not easy characteristics to determine. And then once you know that the fruit should be picked, there might be other fruits as well, and then the system has to make a decision which one I should pick first. To actually perform manipulation and picking of the fruit, the robot also needs to be aware what is a fruit, what is a plant, what is a soft obstacle that you can move aside, and what is a hard obstacle like a table that you should never really touch. And all that has to happen very quickly in real time. Another interesting application where robots can help is so-called in-field transportation. So around 10 or 20% of the time, human pickers actually spend on transporting full or empty trays to the logistic hubs that are in the field. So once you collect the tray of fruit, then you have to take it to a collection point from which tray will be taken to the cold store. So in addition that it takes time, so valuable time and labor from the human pickers, that also requires to dedicate specific part of the field for transportation. So up to 10% you might need to dedicate for a space where the larger tractors have to have access to, and so that's another issue with this solution. An additional aspect here is that the picked fruit needs to be transported back to the store very quickly. Otherwise, any extra hour that fruit spends on the field results in shortened shelf life. So this affects the fruit quality. So here is an example of a system that we developed in our projects, which shows that you can actually perform the transportation task using the robots. So how this system works, so a human picker picks the berries, and then when the tray is full, it's got a device, for example, a mobile phone, where it can indicate that it needs the transportation service. And such a robot knows where the picker is, comes to the picker, collects the tray, provides an empty one, so the picker can carry on picking whilst the robot takes that tray to the logistics center and brings it to the store very quickly. The robots can also be used to help with plant treatment or crop care. So many of the modern strawberry production sites are susceptible to diseases. So different type of fungi So this is related to how the strawberries are grown. And to treat this fungi, we need to use lots of chemicals which need to be applied on a regular basis. So this is an example of a berry affected by a fungal disease. So you can see that this does not look very healthy and that the strawberry cannot be picked. So again, here we've got an example of a treatment that does not use any chemicals. So this is one of our robots that is equipped with ultraviolet light, which is applied during night so that it's more effective. And so what happens is that this light, which is used, for example, in medical industry to sterilize things, so this light kills the fungi without the use of any chemicals. It can be used also in other crops, not just strawberries, but also in vineyards, and also to kill other diseases like, for example, mites. Other areas where robots can help is also for monitoring and forecasting tasks. So these are tasks that enable the farmers to understand how good their crop is and what to expect in future. So forecasting is basically giving an answer to the question how much berries will be harvestable in a number of weeks, let's say in 2 or 3 weeks. And this is a very important tool because that allows the farmers to negotiate the price with supermarkets, reduce the waste, and also plan labor accordingly. So current systems are very unreliable and still are based on farmers' intuition. And one of the key difficulties to make a good forecast is that actually you need to understand how many berries at different growth stages, so how many flowers, how many unripe and ripe berries you've got, so that you can forecast how many of those you can expect in the future. So this is an example of such a technology that shows a system that is able to detect and track, so we can see that this tracks is individual berries over time. So, and by counting these tracks, you can actually provide an answer to the question, how many berries do I have in the entire farm? And that can count flowers, it can count ripe fruit, but also unripe berries. And you can deploy it on the mobile robot, as we've seen here, but also on a mobile platform and device. So there is a University of Lincoln startup called Fruitcast that looks at commercialization of that technology. I'd like to now talk a little bit about the technology that is behind our robotic systems that we develop. So the key component really that enables all these applications that I've demonstrated is autonomous navigation. The robots that we develop, they are autonomous, so they can operate on their own. And the key thing is to go from one point to another without human intervention. So here we've got an example of a system that we use where we can see a form of a map. So this is called a topological map that has got a set of nodes which are associated with different parts of the farm, for example, which are located at the entrance to the rows. And the robot is able to use GPS to localize itself, to find out where it is in the farm, and then is using sensors like lasers and cameras for obstacle avoidance. So these topological maps, they indicate key connections in the field, as I mentioned, and they allow us to send robot to any point in that environment. They can also coordinate work between multiple robots. So, for example, here we see 2 robots being deployed in a farm and providing services to two farm workers. And we can see that this system, this map, this topological map, enables actually coordination of the works So not only plan the navigation for a single robot, but also resolve conflicts. So one robot waits for the other when it finishes. So all that is done in automatic way. Of our other examples of deploying robots in agriculture include a two-robot system for applications in viticulture, so in vineyards for grape harvesting. So this is a two-robot system that is developed as part of the Bacchus project, which is a large project together with our European partners, and it includes two platforms. One is the inspection platform, so a robot that you've seen already before that is equipped with lots of sensors and is able to basically detect all harvestable bunches, grape bunches, and this is how the robot looks like in a vineyard. And then the second robot actually uses that information from the inspection platform to come and harvest that grape bunch. And we can see this is a completely different configuration, different robot. It's got two arms, and one arm is equipped with a cutter for cutting the stem of the bunch, and the other one has got a soft gripper which enables careful handling of the grape bunches so that the bunch can be picked and stored in the tray. And this is video that shows the robot interface and where we can see the collaboration between these two robots easily. So what we can see here is this is the map in a vineyard. The inspection platform is deployed and navigates along the row. At the same time, it detects and geotags the bunches, the grapes, and puts them into a form of a map and a database. And we can see here from the UAV how that process looks like. So the inspection platform navigated the whole row. Then that information is shared with a harvesting robot, which was standing just there and waiting for the inspection platform to complete the task. And once that's done, the harvesting platform commences and starts its selective harvesting task. So we can see the harvesting robot starts moving into the desired position. And when it reaches its position and the grape that it's harvestable, then it uses this dual arm for the picking operation. So we can see here the soft gripper gently handling the bunch, and the second arm with the cutter and the camera approaching the stem, which will be cut, and then this bunch will be then stored in the tray. Other useful applications of robotics in agriculture include robotic weeding. So this is a collaboration with our industry partners who are actually manufacturing and selling a selective mechanical weeding platform. So this is a vision guided mechanical hoe, which again does not require any chemicals for weeding operation. And we can see that this machine is able basically to use that mechanical hoe and get rid of weeds around the crop. And our team was working with the company on the next generation of systems that enable that component to see what is the crop indicated here in green and what is a weed. So this system is using modern AI vision systems to discriminate between these two categories of plants, so which one is crop and which one is weed. And the system is trained on images of weeds and crop and learns on its own what is the visual difference between these two different types of plants. I have demonstrated, I hope, very exciting examples of application of robotics in agriculture. And we've seen some very successful demonstrators. However, there is still a lot to do. The key issues that our team is currently working on is, for example, safety. How can you perform the safe operation of the robots? How you can reduce reliance on human supervision so that maybe a single person can supervise 10, 20 robots at the same time. Second aspect is price. Of course, everyone wants the robot cheap. Currently, the sensors that these robots are equipped with, they can cost almost half of the price. So there is a big interest in technology which does not rely, for example, on expensive lidars or GPS, but rather uses cameras which are inexpensive. So there is lots of research in this area. And finally, scalability is also an issue. We can see here, for example, a map that we use in our systems of a strawberry farm, commercial strawberry farm, and we can see how big that map is. And this map was created by hand. So you can imagine how difficult deployment of robot is, and therefore we work on technologies that enable, for example, to generate this map automatically. So if you think agri-robotics is cool, I do, so then the question is, what skills do you need to actually get involved? Robotics is a very multidisciplinary research area and requires both technical but also soft skills. So on technical side, you need to have general interest in technology, so such as robotics and AI. It's good to have good science background, so maths and physics, but also some engineering skills, manual skills in electronics, mechanics, and being able to use computer hardware. Modern robotics depends a lot on programming, so programming skills are the key. Languages like Python and the knowledge of different software libraries. But also soft skills are very important. You have to be passionate about the subject and also very creative, because lots of solutions are novel, modern, and that requires completely fresh thinking. You also need to be a good team worker. So these systems are so big that it's impossible for a single person to develop everything on their own. And because you work in teams, you also need to be good at communicating concepts. And also working with teams requires good personal organization so that the entire team can work towards a common goal in an organized fashion. When your time comes and you want to apply for a university and you would like to do agri-robotics, there is many options. For example, at the University of Lincoln, you can study undergraduate programs, so Bachelors of Science in Computer Science, for example, engineering, or a new program in robotics. When you finish your degree, you can then go in further education, so into postgraduate programs like, for example, MSc or Master of Science, Robotics and Autonomous Systems program, or Agricultural Science and Technology. So these are all options that are there for you, and I hope that some of you got inspired today by the technology that I've demonstrated and will choose agri-robotics as their future career. So I hope that you've found this lecture interesting, that you have enjoyed at least some of this content, and I'd like to thank you for listening, and goodbye.